as follows. Let me just okay. All right. So what is relative velocity? It is just how fast something is moving compared to something else. Okay. Um, in this case, we are basically looking at two cars. So let's say if I have a car A, okay, this is car A, and let's say car B. Okay. First, we will try to understand this logically through reasoning, and then we will dive into vector addition and just get a feel of the mathematics of this concept. All right. So let's just say, let's just look at this first bullet point. Now, if you are moving in a car and it's going 60 kilometers per hour, and it's moving, let's say in the same direction, right? So let's just assume that the car is moving east. So this arrow denotes the car is moving in the same direction. And then let's also give the same direction to this car B here. Okay. Now, in the first scenario, both of them is moving 60 kilometer per hour in the same direction. So if I ask you how fast, okay, how fast is the car B moving relative to you, and let's say you are in car A. Now you can close your eyes and imagine that you are let's say traveling on a highway. Let's say you're going to Suva and you have this a two-way traffic stretch, and it's a very straight line. Okay, there's a straight highway. Okay, let's say something like this, and it's a two-way traffic from this side, and then you have this on the other side. And let's say these two cars are traveling here. Okay, so both of you are traveling at 60 kilometer per hour, and it's a straight line. So regardless of the trees moving around in the background, just close your eyes and just imagine two cars moving at a constant speed. As I said in the first day, will you be able to distinguish, will you be able to differentiate how fast one car is traveling from another? Okay, well, there's no pure answer to this, but with logical reasoning we can say no. Okay, since both the cars are moving with 60 km per hour, both of them appear to be stationary even though they are moving. So if you are in car A traveling at 60 km per hour to the right, car B also traveling in the same direction and the same speed, it will appear to be stationary. Okay, it will appear to be as if both of you are not moving. Now, what if, let's look at scenario B now. Okay, we're looking at scenario B here. Now what if the other car, when I say, let's say car B, is moving at 80 km per hour now. Now instead of 60, it's moving at 80 km per hour. Alright, now in this case, you are moving. In this case, the car B is moving 20 km per hour faster than you. How did I come up with this without any math? Okay, you know that both of you are moving at 60, and this car B is moving 20 km per hour extra. Okay, that means it's going 20 km per hour faster than you. So without any mathematics, we know it's moving 20 km per hour faster than you. Okay, this is something that I always encourage. Think about the question first, and then move into the mathematics. This was a very classic example of how Einstein used to solve his problems. He would go ahead and do this thought experiments. So you think, exhaust your mind, okay? Use imagination and just think about the question, and then you can make mathematical directives. with your thought experiment. Okay, so I'll move forward. Let me just scroll here. Let me just scroll this. Okay, okay, here you go. There's the eraser. Alright, so we have this another example which I would like to show you mathematically as well as think about it logically as well, right? So let's just go ahead. Okay, alright. Okay, now imagine you're walking on a road, right? Heading west. So let's just be very clear with our directions here. It's north, that's your um, east, that's south, and this is west. So a train track runs parallel to the road and a train is passing by, traveling at 40 km per hour west. There is also a car driving on the road going 30 km per hour east. Okay, so there are three things that are happening here. Okay, first of all, let's say there's you who's walking 8 km per hour this direction, which is west. Then there's a train to walk, so not walking, it's traveling or moving at a speed of 40 km per hour, and it's moving west as well. Only thing that is moving opposite to you is the car, which is traveling 30 km per hour east, which is in this direction. Okay, so how do I solve the first question? Find the velocity of the train relative, okay, relative to you. Okay, I want to find the velocity of the train relative to you. So mathematically I'll write something like this: the velocity of the train relative to you, alright, is the velocity of the train minus the velocity of yours. Velocity of you, this is how I write mathematically. Now via logical reasoning I can also understand that if you are moving at 8 km per hour and the train is moving at 40 km per hour, okay, these two scenarios, okay, these two scenarios, so the velocity of the train relative to you, which means how fast is the train moving with respect to you. Now you can think about this just as just like the way we thought for the previous example. If the train is moving 40 km per hour left and you are also traveling in the same direction, okay, that means you are already 8 km per hour, okay, in path with the train. You both are moving in this direction. If it's traveling 40 km per hour, you are also traveling 8 km per hour. That means the train is moving the difference of your velocity and the train's velocity. Okay, so that is basically 40 minus 8. Alright, so it's just 40 minus 8, and that is, I guess, 32. Yeah, 32 kilometer per hour. So that's basically the answer, and it's moving to the left. Mathematically, let's look at this. So what's the velocity of the train? It's moving 40 km per hour and it's moving to the left, minus velocity of you. You're moving at 8 km per hour, also left. Okay, now what did I tell about the subtraction of vectors? You cannot minus the vectors, right? So you write 40 here, keep the vector as it is, put a plus sign here, and then change the direction, put a 8 there. Okay, now this, let me just change color. Okay, now this arrow here, this vector, since it's moving to the left, this is telling me that this is a minus 40. Yes, because of this vector moving to the left. And this vector, since it's moving to the right, telling me that it's a positive 8. Okay, and negative 40 plus 8 is basically negative 32, and this negative sign tells me that this 32 is moving to the left, and therefore it's moving 32 kilometer per hour to the left. Okay, now once again you can use logical reasoning as well as mathematics vector addition to solve this problem. Okay, so I have done one example for you. I have explained how logical reasoning is important to understand problems. And always try to write things down like this. See, try to write things down. Now why? So that you don't overload your brain with information. I know numbers and physics sort of can cause confusion while solving problems, so always write it down so that it's much easier to work with. Okay, so I have done one example and I've explained. I want you to do just for the weekend, I want you to do this B and C. This will be your activity, let's say Sunday activity. Try to do this B and C, and you can check with me in school, as well as I could you could write your answers in the comment section and I will just say it's correct or not, right? So have a blessed Sunday. I'll see you in school, and I'll continue making more videos as we go along the course. Have a great Sunday. Stay blessed.